Kia ora guys, today we are going to look at page 21, and page 21 is all about, given a z value, what is the probability? Now there's three ways that you can do this. So the first way is that you can use your graphics calculator if you have one of those, but we don't really expect that you have one of them. So the standard way we're going to do it is using this table, and this table will be given to you in the exam. There is actually one other way if you are not into that, but you won't be able to do this in the exam, and that's using this, which is this desmos graph. So what we're going to do is pretty much, we will just go straight to using the table, I think. Okay, so first of all, they have given you a z value of 1.3. So what that means is on this graph, it means that we are looking between the value of 0 up until the value of 1.3. So in my opinion, they've actually sort of asked the question a little bit wrong. It should look something more like this. It should be, what is the probability that the random variable is between 0 and 1.3, and this is using the z distribution. So a fancy way to write this is, you would say that z is between 0 and 1.3. So this is really how it should be written. Given that the z value is 1.3, what is the probability that the random variable takes a value between 0 and 1.3? So this is the proper fancy way of writing it out, but just so that we can do the bookwork, we'll just pretend that they make sense. Okay, so 1.3 is what we are looking for. So what we do is we go to the back of the book and we go down to 1.3, and because there's no number after 1.3, we're going to assume it's 1.30. So the probability is going to be 0.4032. So all you need to do is, on page 21, oopsies, I already forgot what this number was, 0.4032. So 0.4032. That's how we're going to do it. But just because I'm going to show you how to do it on the calculator. So on the calculator, go back to the menu, click on Stat, click on Dist for distributions, which is F5, then go to Normal, we're looking at the normal distribution, C for cumulative, that means we're looking between two values, and so we're going to look between 0 and 1.3, and the standard deviation is 1 and the mean is 0 because that is the standard normal distribution. Let's click Execute, and there you go, 0.4032, because we would round that up for 4dp. And then the other way to do it, so let's look on Desmos, you could just put in mean of 0, standard deviation of 1, that's the standard normal, and we're looking between 0 and 1.3, and then down in here you can see that the probability is 0.4032. So those are the three ways of doing it, but today we're going to do it from the table. Okay, let's look at the next one. 2.75, we're going to start rushing them a little bit. 2.75, we go down to 2.7, and then we go across to 5. Where was it? 2.75, right? Here we go. It's 0.4970. 0.4970. So what is it that we're actually asking again? We're asking between the number 0 up until the number 2.75, and so the probability is 0.4970. Okay, what we're going to do is we're going to skip these because they're very similar. We're going to go to one that has 3 decimal places. So this one's 1.645. So what we're going to go to is we're going to go down here. We're going to go down to 1.6. Then we're going to go across to 4. Right, so it's 0.4495. Oh, I'm going to write that down. 0.4495. 1.64, double checking it, and then we have that little difference of 5. So we have to go to the differences column, so we go across here until we get to the difference of 5, and here it is here. And a difference of 5 means we have to add 5 on to that number. So it's going to be 0.4495 plus 0.0005. So that is actually going to get us to 0.4500. Okay, so then the probability is 0.45. Okay, let's see if there's any harder looking ones. This is going to be much the same. You're going to, whenever there's a third decimal place, you're going to go into the differences column. So that one you're just going to get 8 in the differences column. This one here is going to be fairly straightforward, Why is this one hard? I think that this is a trick question. Let's have a look at this. Question 8. So let's go to 3.9. Now, we go down here. Does it go down to 3.9? Yes, it does. But notice that all of the values of 3.9 are 0.5. So it sort of finishes at 0.5. And I just want to show you guys why that is the case. So let's drag this thing across. And we're going to keep increasing it. See how the area fills in at about 2. A lot of the area is filled in. And then at 3, pretty much most of the area is filled in. But if we go to 3.9, at this point, the number is so close to 0.5. See, it's 0.499995. It's getting so close that it's pretty much anything from that point onward is pretty much just 0.5. This graph actually goes for infinity. It's always there, but the values are so tiny that they become irrelevant after a while. So the answer to that one's pretty straightforward. It is 0.5. And I think that should help you guys finish page 21 pretty easy.